Cats, as many other wild animals, mostly do two things: hunting and sleeping. Hunting provides with food which supplies the cat with energy for its activities, like running and climbing, producing sounds, idling, and further hunting. Even when a cat does not move, it still needs to maintain its body temperature and breathe. Expanding and contracting lungs while breathing also requires energy, and it supplies body with oxygen so vital for oral chemistry and internal energy generation. I keep saying energy, but what is energy? It might seem a different thing if asked in the context of cat's metabolism, some process and physics. Yet the concept of energy is so fundamental that it permeates pretty much everything. But the question of what energy is usually produces considerable confusion. So let's try to work around it. Energy is one of the very important quantities in physics and nature which is involved in all events. Literally, if something is happening, you can be sure that there is energy or change in energy associated with it. Also, energy is quantifiable, meaning that it is indeed possible to calculate how much energy there was, there is, or there will be. Energy is conserved, it cannot just appear or disappear. It can change form, but the overall amount will always be the same. And knowing this is very helpful for working out many problems in physics and engineering. But what does it mean to change form, not appear or disappear? When we talk about energy generation, say at an electrical power station, generators do indeed generate electrical energy, but they use kinetic energy released, for instance, for burning coal, atomic reactions, or water motion. So essentially they are converting other types of energy into electrical. For example, in case of atomic reactions, the energy released due to radioactive decay is used to heat up gas that rotates a turbine connected to generator's rotor. So internal energy of radioactive isotope is not directly converted into electricity, but is first converted into kinetic energy of hot gas, which is transferred to rotating turbine, which is finally converted into electricity. Might seem confusingly complicated, yet not always one can convert energy into the desired type directly. Also, there is always some energy loss involved, so we would have also generated some heat which plays no part in our electrical energy generation. And the more heat we generate, the less efficient our electric generator is. We need to provide paths for energy to flow, both when converting and transferring, and an obvious example of a transfer path is high voltage power line that transfers electrical energy between a source and consumers. Otherwise, energy flows in all possible directions when no preferred path is provided. For instance, Sun supplies our planet Earth with light and heat so essential for our existence, yet it emits it in all directions around it. We just happen to be in one of them as we rotate around the Sun. We receive a small part of the total energy emitted, and it is fortunate that we do not receive more. Energy emitted by Sun is transferred by electromagnetic waves which can be absorbed or reflected. When absorbed, energy of a wave is gained by a body absorbing it, and when reflected, energy is kept by the wave and it keeps on traveling. Sound waves are similar. They can be reflected and bounce back and forth as echo in mountains until they are finally heard somewhere. So all energy goes somewhere, but not necessarily where you need it to. When you work, your energy follows your attention, so be considerate of what you are paying attention to. It is possible to focus by eliminating unwanted paths. But in general, in physics and engineering, energy never follows one unique path, and the energy not following the desired path is considered as a loss. The most common form of energy loss is dissipation in the form of heat. This is particularly important for engineers, since undesirable heat can lead to malfunction. And even if it does not, you still have done some work producing that undesirable heat. But what if you do not want to spend energy? What if you want to preserve it? It is almost never possible to avoid loss completely, but you eliminate as many paths for energy outflow as you can. Think about a sleeping cat. A cat needs to maintain its body temperature, since it naturally loses heat to the environment. So first, a cat tries to find a warmer place, another heat source, or a place shielded from cold. But among internal factors, the only way to maintain body temperature is to minimize heat outflow. And since heat flows in all directions from a cat like from a sun, a good idea is to make some of these directions go back to one's body. So being flexible as cats are, they accommodate somewhat a circular shape. So heat from internal parts of cats' bodies trapped inside and doesn't leave. On the outer parts are paths for heat to leave, yet they are also preserved with fur. It is important to remember that fur, like human clothes, doesn't generate heat, it bears the change. Similarly, clothes are not necessarily warm or are used to make things warmer, they just prevent internal from interacting with the external. So, back to the cat. For a circular shape, outflow area is minimized, so cat can sleep better. There is actually something fundamental about circles, minimal principles, and energy. Also, if energy is always converted and never actually generated, where did the energy come from in the first place? But I guess that's a topic for another day. Today, let's just make sure that cats do not get cold. Thank you for watching, and see you next time.